Great. So yeah, I was originally going to talk about symbols, iterators, and generators. Oh my! But we're just going to cut the last two part out because this is pretty extensive itself, and I feel like you should absorb everything one at a time. So today we're going to be talking about symbols because we're going to be exploring stuff that you don't want to explore. In hand, when we think of symbols, or when I think of symbols, is what the crap is this? Have I ever used it in production? Nope. Will I? Maybe. But we're going to explore on the use cases, why is it helpful, and why do you need to know? So with symbols, aka snowflakes, because they're unique and guarantee never clash. Don't worry if you don't understand this right now. We're going to have a couple examples to see why that's the case. They're typically used as property keys without risking name collision. They're great for when you have shared objects and when you're a library author such as myself and you don't want to mutate your client's code because you don't want to break shit. So adding new functionality to the language without breaking the existing code. This is exactly what we need. And they provide an encapsulation for privatizing these properties that we're going to be making. So yes, they're the 7 primitive symbols. And this, yeah, I felt like this was an appropriate meme. But how do we create symbols? Well, it's really simple. We have to keep in mind that when we are creating symbols, they are functions and they're not object constructors. So do not put the new keyword or you will get a type error. And basically you would invoke the symbol and you would assign it to a variable in itself. And each symbol is unique and guaranteed never to clash. So in itself, if you strictly equal both foo and bar, it's going to be equal false because they are unique and they're snowflakes. So what can I do with symbols? Symbols as property keys is the most common case where we use symbols. They never clash unlike object string keys, and they are designed to avoid collision. So in the example which I'm about to show you, it's about shared objects, and using symbols as a property key would create 2 different properties. Bless you. And there's a lot of extra specialness I'm going to show you besides just being unique in its own case. So an example of symbols so far is we have an object and we are declaring 3 variables which we are going to invoke with symbols. The first address is going to be the borough. The second address is going to be the borough. As you can see, this plays on for where Fred lives, and Fred is age 20. I believe that's when he died, right? Yeah, just about. So for the email itself, we have we have an email, we have address, and we have assigned both those properties as property symbols on that object in itself. And if we were to console log it, as you can see, even though we have the symbol for the borough, whenever you invoke a symbol and add a string to it, you're just providing the description. But as you can see, there's no clashes. You can have the same property symbol as well as the same values, thus making it unique. So when has this ever occurred? So name clashes in JS standard libraries, it doesn't occur often, but it has occurred in the past, which made it a big deal. In the past, before string array.prototype contains clashed with a method added by MooTools. I've never used MooTools myself. I don't know what that is. But it had to be renamed to string array.prototype includes. And there's a description of the bug below. And it's essentially this. Let's talk about a little bit about secret properties and what do I mean by private properties in itself. They're very low key. You can't access them by the dot syntax and you have to use the square brackets itself. And most object inspection features will ignore symbol keys in itself. So you can't use object.keys on it, and you can't use like property has own. So it's ideal for properties that you don't want to be included when serializing an object. And this was like what I thought how privatizing properties would be like. But let's take a look at the example. For the example itself, we have an object and we're still using email as the variable name, and we're going to be invoking the symbol on it. With user.name, we have Fred and we have an age of 30. He made it past 20. For the user email itself, we have the same email. And if we try to use keys, all we can see is the name and age. We can't see the email itself. And if we use get own property names, still no email. When we stringify it, no email. And when we use the for in loop, there's no email. As you can see, it's kind of privatizing it. It's kind of keeping it secret. But there's some sort of lie to my truth in itself. It's not completely hitting. And with the new reflection API, that provides a lot of methods onto how to access these symbols in itself. And symbols aren't always guaranteed for privacy. The the main point of symbols in programming is to sprinkle it onto your existing code and change the behavior without messing everything else up. And with that said, you have two methods that you're able to act symbols with, and that's get onProperty symbols with the object that you have the symbol in for, and you can use the reflect API with onKeys and pass in this object in itself to retrieve that. Cool. We're going to talk a little bit about global symbol registry. We've talked about how unique and how localized and how private they are. However, in this case, symbols provide a great context where you can share it across different execution contexts. So what I have on the second point right there is a browser, a web page, an iframe, a web worker, all could have their own realm within their unique global objects, but they can share symbols within this global registry. So it's kind of like this global environment where you can access the same symbols and use them throughout all those different types of registries. So with that being said, you can use the symbol.for or the symbol.key4 to set and retrieve symbols from the global registry. An example of this would be if we look at the top hand, that's kind of the same example that we had on the first slide, where we are invoking two symbols and we're going to do sim A and sim B. If we strictly equal them, they're going to come out to be false. However, when we use the global registry power, these are going to be shared registries, so you can have them with the same description and they'll be strictly equal to be true at the end of it. And you can use key4 to identify that object that you're looking for. So there are a lot of well-known symbols, and this is going to be the most prevalent case of where you'll interact with symbols. They are predefined properties of the symbol function, and you can customize the behavior of certain language features. I'll show you what I meant by supporting meta-level methods, but the most common well-known symbols is the symbol iterator. And that's why I kind of attach with symbols, iterators, and generators, because in this case, you'll understand it in more context, but I'll talk a little bit more since it's going to be in the slides ahead of us. So in itself, symbol.iterator is a well-known symbol that's used to assign objects, and it's built into most arrays, typed arrays, maps, and sets. Before I proceed with the slide forward, all you have to really understand is that when you invoke symbol.iterator, it's going to return an iterator object. That in itself is going to have a next method, and it's going to return what's called the iterator result object, which is going to have a value and a done. This is kind of what drives the for of loop, as well as the spread operator for the methods that you're using in JavaScript. So kind of a way to implement your own iterator or kind of try it out yourself is that you can have an array and you can invoke that symbol.iterator method on the array itself. It comes with all the iterables that I've discussed about before with arrays, sets, and maps. And like I said, it's going to return the iterator object that's going to have a next method to it. And that next, once it's going to be invoked, it's going to return an object with a value and a done. So it's going to iterate Freddie, Brian, John, and Roger, and after that, after it's going to be done, it's going to set the Boolean to be true, and that's when it stops. So kind of what I've inspected before was that these symbol.iterators, or these symbols in general, drive the functionality of your methods in JavaScript. One of the examples that I talked about is the for of loop. So on the top example with the for of loop is a typical for of where you're iterating through the array itself, but you can apply your own iterator to iterate that through. And for the second example itself, as I'm invoking that symbol.iterator and assigning to a variable, I'm saying that if, once I'm assigning that if next is still true and it's returning an object and done is not true in this case, I'm going to keep iterating through until it's true, and then I break out of the loop itself. And it's going to provide me the same values of 1, 2, 3, and 4. So there's a lot of caveats when it comes to symbols itself. You can't try to concatenate a symbol with strings because they're not strings. And you can use the in operator as well as deleting properties of symbols. You can also object.assign to copy these properties over to a new object. So an example itself, can you see? Why is it showing up? Okay. If I scroll down, nope. So on the top example, I have sim, let sim equals a new symbol in itself, and it's a heart shape. And I'm trying to concatenate it with my current existing string. Both of them are going to give you type errors, either when you're using a string literal or just concatenating them with the plus operator. And the second example in which I have for it is after I've declared my object with this symbol as a property, I can use the in operator to check if my values exist. In this case, if it does exist, and I'm going to console log, I can see your email, even though email is going to be assigned to a symbol in itself. And I can also delete the symbol property on the object. And you might have experienced symbols before in Ruby, but they're not the same. They might share the same symbol registry. However, for Ruby symbols, they are literals, and they will kind of reproduce the same results, as mean they're strictly equal to each other, in the case of JavaScript, where they're both unique and special snowflakes. And the different use cases that which we'll use symbols for is that you can use them to hide your properties that won't be included in the object serialized. As a library author, this is really cool to kind of safely augment your client's code base. As well as, symbols are kind of what exists under the hood, so understanding them better may understand the methods that you're currently implementing within your code base. And thank you.
How long have symbols been supported, or like how old can you go back as far as Bible support?
5 years ago.
Oh wow.
Yeah.
So 10 and 11, do you know?
Maybe I-11.
Okay.
I'd say that's when they were first thinking about implementation it, and it was still within stage like 3 or 4. Cool. I mean, I think symbols are just not that complicated, like once you know the basics of it, and with this carried away, that's as much knowledge that you need for kind of production code in itself.
Question. So I still want to poke a little bit into the main reason for bringing them in.
Yeah. So yeah, that's a great question, because I try to find like use cases in which this was a problem, and I think that very early on, just like with so many different JavaScript libraries out there, if I can find a use case for modules, and in itself kind of like stepping over each other's code, this was kind of like the main reason. Did you guys see it? Here we go. Non-clashing. There aren't too many examples of like why this was so necessary, considering that there were only like 3 bugs within MDN of which was classified for. I think this was just kind of like in advance with the new Reflect API and with like implementation of better metaprogramming that they wanted to implement symbols.
I can add to that if you want me to.
Yeah, go for it.
Yeah, so if you go back about 5 years to a little bit to a different time in the JavaScript community, the language was very, very different. And people were constantly introducing libraries like mootools, which the way mootools worked was it overrode the prototype of strings and arrays, which meant that it added a method to every single string and every single array. And the problem is, if browsers started implementing that, it would break that functionality on older websites. Now, one of the biggest rules for the web is that we cannot break older websites with newer browsers. So as a result of that, newer browsers will always be backwards compatible to older websites, even from the early 90s. And they can't break things that are potentially using mootools, because at one point it was a very popular library and many, many people were using it. So symbols are a great workaround for this, in that they've said, okay, we need people to be able to expand the language, especially with like how Babel works, or TypeScript, or all these other utilities that we're using today. So they've said, let's come up with better primitives and let's make these work better under the hood. So that's the history behind that.
Yeah, I think it's a separate thing though, because enhancing behavior, which is what libraries used to do and continually used to break like each other, is different than applying or putting metadata on objects by using symbols, because this is essentially just applying hidden metadata. It doesn't change behavior in any way, right? Yeah,
it shouldn't, because they're unique.
So you don't enhance anything, you don't change anything, it's just hidden, it's just for you. You know it's there. It's basically just for things like it's interoperability. But is there another way to solve this? Isn't this being solved by weak sets?
Oh, I wish I knew, and I'd be making the big bucks, but.
Just curious, because it feels like I'm working around for issues that shouldn't be.
Yeah.
Are weak sets new though? Are weak sets themselves newer? As a function?
I don't know.
Yeah, ES6, weak sets and weak maps.
Newer functionality.
I don't know.
It's a good question, but by that question, why have a lot of different types of ways to do the same thing? Why have anything more than a
Yeah, I'm curious. It's kind of cool, but I struggle to find the valid use case.
Yeah, and I think that was like my biggest concern, like going through and giving this presentation, like if there are any great use cases out there that wasn't like 5 years or 10 years old regarding one specific library in itself. And I just couldn't find it. I mean, I went through all the Mozilla Bugzillas. There was only like 3 cases, and this was the most prevalent one that I saw so far. But I think that you make a great point of, asking yourself as an engineer, like, why do we really need this? Is there another workaround with an implementation with a new version? Great.
Are there like big projects or any companies that are using symbols right now? Or
Not that I've known of. I mean, I went through mostly the entire React library source code and haven't seen symbols yet. But if you do,
for generating like unique entries,
Mhm.
right? So it's like auto-incremental key.
Yeah, the only examples of where I see symbols implemented is kind of like under the hood for JavaScript prototype methods, and that's about it. I mean, that's in a good case for myself, a good argument, because you're using language in itself, and that's how it works under the hood. Great.
just a point of clarification. So you said regardless of the symbol's context, like wherever you make it, it'll be globally available anywhere else?
Yes, as long as you use the global registry, which is symbols.4. It works across different contexts. Mhm. Thank you. Great questions. Yeah,
That's all we
thanks.
got. Thank you guys for coming. Really appreciate it. And be on the lookout for next month. So, cool.
Appreciate it. Yeah.
Break.
Thank you.
Cool.